Right, good stuff, folks. Thanks for joining the session today. My name is Federico. I'm a staff engineer in the SRE team at Wise. Wise, a fintech company in London, headquartered in London. I've been with the company for a few years. Before that, I've worked in consultancy for many years, working with banks and companies in the financial services space across different countries, different regions in the UK and Canada. My background is infra, cloud architecture, and system design. Today, we have only 30 minutes for a talk that is designed to last 45, so we're in a rush. This will be an intermediate plus/advanced level talk. So if I go too fast, if I cover things that just are not clear, you can come to me at the end. Be more than happy to answer questions and deep dive on any of the topics we cover today. So Kubernetes has been the focus of a number of talks this morning and this afternoon. Don't want to bore you too much with this. But I want to draw your attention to one thing, which is Kubernetes is old. This is an old technology. Kubernetes was released in 2014, was open sourced by Google. Cloud providers starting adopting it and offering managed services for it. The first one was GKE on GCP, and then AWS as well, Azure with all the others. They have been there for 10 years, at least 10 years of cloud providers managing services with Kubernetes. We have a very mature ecosystem. The number one reason why people in large enterprises tend to adopt Kubernetes is because of portability, because people believe that Kubernetes is portable. Oftentimes I hear people saying, colleagues in the industries or clients I used to have in the past, they would tell me, okay, we are adopting Kubernetes, we're using Kubernetes because it allows us to move an application from one cloud provider to the other. We want to move from AWS to GCP with Kube. This has been true forever. Since 2023, 2022, there were talks out there. Kube is the standardization layer across all of this. Today, together, we're going to see whether that is true or not. So, the mission is for all the people in this audience to help me migrating an application from AWS to GCP. We're a migration team. We have been tasked by our B2B, B2C actually, company to migrate this thing from one cloud provider to the other. You can imagine that we have decided to move the entire stack to GCP. Maybe we received some credits. Maybe we have to do it because we've been acquired. Whatever is the reason, we're doing it. It's a game that we play, okay, all together. Our game has rules. What are the rules? So rule number one is that our landing zone on GCP has been built. GKE, the managed service for Kube on GCP, is up and running. This is a stop the world migration where we turn off AWS and we run everything on GCP, and we can stop the world. So we can stop one side and turn on the other. We don't need to worry about traffic management or ingress management. Everything is done for us, okay? So what I want to say with this is that today we're dealing with a very easy, very straightforward technical migration. Super easy. We have a modern stack. We do have, though, various stakeholders we need to think about and take care of during our migration. We have our backend team, front-end team. Okay, we have our users, but we also have our InfoSec team, our security team. We have our mobile developers. We have our SRE team, our infra team. They all need to be engaged in this migration, need to be taken care about in this migration. Our AWS architecture, let's look at this together. So pretty straightforward. To the left, we have users. Our users have a mobile application on their mobile phone. The application uploads an image. The application talks to 3 microservices deployed on EKS, on AWS. Microservice number 1, HTTP RESTful, is the microservice that manages HTTP calls. It uses an RDS database that should be inside the box, not like on the border, but the rendering is not great. This database is Postgres. So microservice comes in and says, okay, do I have the user in my database? Yes, I do. I check Postgres on RDS. Perfect. The user is then authenticated and authorized, uploads an image to our S3 bucket, and then microservice number 1 uses SNS to send a notification through a queue in system, sorry, SNS or SQS, send a notification to add microservice number 2 that then says, okay, cool, I'm going to add a watermark, I'm going to change the image a bit, and I'm going to send the user a notification that I changed the image using a SaaS tool to send emails. So pretty straightforward. Key components: 3 microservices written in Golang, written in Rust, written in a modern technical stack, a few external services, RDS with Postgres, SNS with the queues, and one S3 bucket. We're using also HashiCorp Vault for a secrets management, and we're using Grafana and Prometheus for monitoring. Pretty straightforward stack. How does it look like on GCP? We've done our tabletop exercise, we've done our tabletop work, and we have a GCP architecture that is the same. It's the same thing. 3 microservices, they do the same thing. Get an image, check the user in Cloud SQL, the managed service for Postgres, load an image to cloud storage, buckets, read from cloud storage through a PubSub, and then send a notification out. And we're swapping HashiCorp Vault for secrets management with GCP Secret Manager. So services to service as a comparison. The architecture looks the same. What is the journey? What is the journey? So journey is start from AWS, change a few things, get to GCP with the promise that this is a turnkey migration. So this is an easy migration. What I want to do right now is to take the YAML I had that describes my app on AWS, change our CI/CD tool, GitHub Action, Jenkins, Circle CI, Argo, whatever, point that to GKE and say, apply. So question number 1, easy question. Question number 1 for the audience. Can I run kube control apply on this YAML straight on GCP? Can I do it? Yes or no? No. Why? Okay, ECR, perfect. So first answer, super easy. ECR, yeah, can I not use ECR from GKE? Yes, but I need to stop credentials. What is the trade-off with credentials? That's a good point. They expire, yeah, okay. Credentials expire. So yeah, I can use credentials. The trade-off with credentials though is, on GKE, as per AWS, I have 2 types of nodes I can use. I can use self-managed nodes, nodes that I manage myself, or I can use nodes in autopilot mode. I can use nodes that are managed by the cloud provider. If I keep my container registry on ECR, what I need to do is that I need to use the nodes that I manage myself. So I need to then take care of the maintenance, the upgrades, the changes on these nodes. That is a trade-off that I'm making. But yes, it's possible. What are the alternatives? Well, option 1, I could decide to use JFrog Artifactor, which is a commercial tool, or Harbor CNCF-backed tool that does the same thing, and I could embed the container registry within Kubernetes. Option 1. Option 2, I can keep the container registry in ECR and use it, or I can move to Google Container Registry. Now, I could choose either way because, as we said, I could use the managed nodes on GKE. But one thing to keep in mind is the fact that we're seeing here that the fact that the container registry is outside of Kubernetes limits our portability a bit because I need to think about the container registry. This is the reason why OpenShift and some of the largest commercial versions of Kubernetes, they have this concern embedded in the product. They're extending the Kubernetes ecosystem to embed a set of external concerns, including container registry. In this case, given it's 2026, the container registries on EKS and on AWS and on GCP are the same. So I could swap them. It's very easy. Push all the image, pull all the images, push all the images, change the YAML. You can automate that. Not a major hurdle. But our security team is unhappy. I can give you some suggestions here, I give you a hint. It's a question for you guys. Why is the security team unhappy with us? Thinking about the fact that when we deploy our Kubernetes managed solution on GCP and our Kubernetes managed solution on AWS, we're using best practices that are agreed upon in the industry. So we're using CIS benchmarks, NIST benchmarks. We're using the best practices that come from those frameworks. So question, why do you think our security team is unhappy with our choice of switching container registry or doing it like this, effectively? Any ideas? This will get you a this will get you a t-shirt. It's a hard question, I know. Containers, perfect. I'm not sure who said that, but that's exactly the answer that we want. Okay, so that's a very good point you have there. Let me be more specific on this. So there's a feature on GKE called binary authorization. This feature exists only on GKE. The feature says we as a company can establish an organizational policy for which within our GCP account or projects, all our Kubernetes clusters must deploy signed images. If the images are not signed, we cannot deploy on it. That feature, binary authorization on GKE, does not exist on AWS. It is implemented through a CNCF solution, Kyver and another tooling, for which we can decide to do it or not. But the point is, we deploy following best practices. In a large company, a large bank, you follow best practices, you have to do it. Those best practices differ between AWS and GCP on Kubernetes service itself, because the two tools offer different capabilities. As a result, this is something we need to keep in mind and something that will have an effect on us. What if we now have to resign all the images that we want to build and change all the CI/CD tooling so that the images are signed? It's a bigger thing. But this is not going to stop us. We have to continue our journey because we only have 17 minutes, so we have to be fast. So next question for you guys. I changed things. Kube control apply. This is an easy question. Can I kube control apply this against my GKE cluster? Yes or no? Silence. Okay. Who says yes? Can you raise their hands? Okay, literally nobody says yes. I imagine that the answer must be no. And you're right. So the answer is no, I cannot. Why? RDS is there. So I need to swap database management system. Can I swap RDS for Cloud SQL? Of course I can. Why can I? Because it's 2026, not 2022. Why am I saying this? I'm saying this because Cloud SQL on GCP and Amazon RDS are very much overlapping today, minus networking, which is very different on one cloud provider than the other, minus authentication, one cloud provider than the other, but they're very similar. So I could move them around pretty easily and I could run Postgres there. No problems, okay? Not a major hurdle. But how could I be more portable than having to think about swapping RDS for Cloud SQL? Well, I could deploy Postgres within Kubernetes itself. If I deploy Postgres within Kubernetes itself, I can kube control apply Kubernetes on the other side. Can I do it? Yes, I can. Can I do it in an easy way? Of course, I have Kubernetes operators that will help me with the journey here. These operators are Postgres operator. The most famous one is called Patroni from Zalando, allows for deployment of Postgres in HA mode on Kubernetes clusters. Super easy. But if I deploy Postgres on my own Kubernetes cluster, then I have to worry about the maintainability of it. I have to upgrade Postgres. I have to think about how it's going to scale, okay? In the same way in which I had to manage the nodes in autopilot mode, I have to think about Postgres. This is a takeaway, if you want, for the session. I want to be more portable? Perfect. I can embed things within Kube and rely less on the cloud providers, but I increase my maintenance cost and my total cost of ownership of the solution. That trade-off may be worthwhile for me or not. It depends on your circumstances. The solution is not a technical one, it's a business case one. It depends where you want to go in the future. Do you think you're likely to migrate? Then embed Postgres. You think you're all in with AWS? No need for Postgres on the cluster. Okay, pretty straightforward so far. Let's continue our journey. One more question. Okay, so I have changed Postgres. I have changed container registry. I deploy the images, I deploy the applications, It's up and running. Microservice 1, 2, and 3 up and running. They pass readiness check, they pass liveness check. Everything is fine. So I go and tell my users, hey users, can you please upload an image with your phone and see if that works? The user goes there and tries, gets an HTTP 500. Why? Any ideas? No, there's no cognito for authentication. It's a good point. But no, it's pretty straightforward like this. We're authenticating our users just with microservice 1, just API keys, something super easy. Ingress and load balancers, super good point. But it was one of our rules at the beginning. We said, we don't care about that too much. It's too complex to manage here. Sorry? So storage is a good point. In this case, what we're changing cloud storage for S3. Exactly. So once again, similar question. Can I keep the objects in S3 and fetch them from GCP and GKE? Of course I can. Yes, I can. Because I'm just going to have to authenticate against S3. How do? I do it with the usual flow. I can store them on the nodes themselves. I can add the service account on the nodes. But if I do that, then I need to manage the nodes myself. Two options. I can move to GCP, straightforward, or I could use effectively kubefs or Rook that allow me to manage S3 within my own environment. Is there not a better way, though? Can I not be more clever than this? Within Kubernetes tooling, yes, I could. Rather than swapping S3 for container storage, what I could do, I could use container storage interface. I could use this capability of Kubernetes. Who has used container storage interface in the past and who knows, like, deployed it? A few people. Perfect. Nice. Pretty straightforward. The way in which flows this is easier to show than to explain. What is happening today is that our microservice is making an HTTP call to S3 and is saying, okay, give me the object back, okay? I can swap it. I can say, rather than calling S3, try to read from a volume, from a folder that is attached to the container. If you read from the folder attached to the container, that then the container storage interface converts into an S3 bucket. It's a fuse mount. It's a capability that Kubernetes has. If we do this, if we expose the object as a folder, then swapping is super easy because I swap it behind the scenes. The application doesn't see a change. Of course, not a perfect solution. Why? Because we have POSIX limitation, because an object storage is not a file storage. So permissions change, the way in which you manage those files change. It's not a perfect solution, but there are a few open source projects that support it. So this allows you to be a bit more mobile, I think, around all of this. So we're moving to GCS. We're moving to Google Cloud Storage in our example because it's easy. But if we move to Google Cloud Storage in our source code, we have to change the SDK. I have to move from AWS SDK to the SDK, to Google's SDK. I can do it, but you can want to hold your thought there and say, okay, I can do it. Typically, storage layer is very well managed, so it's not super hard to do, but it's something to keep in mind that we have to do. Okay, let's continue our journey. I've changed database engine, I changed container storage registry, I changed storage system. Can I kube control apply this YAML? Can I do it? Yes or no? Can I go on GKE and say, hey GKE, I used to use SNS. Can you please use PubSub now? So can I, without changing the application, only change the configuration of the app and point the environment variables to a different service on a different cloud provider? Yes or no? No. Authentication is a problem, but also they're two different services. Yeah, they're two different services. They do different things, right? One is SNS, the other is PubSub. They're totally different services. So I cannot use them. I can just swap the environment variable like that. But why? Why are we not able to do it? Because if you think about this, One microservice sending a message to another microservice is a standard that has been in the industry for 40 years. In 1980s, using enterprise service buses, services would send message to other services, right? It's that easy. We're making a cursory use of a pattern that has been in the industry for 30 years. And yet I can swap the environment variables. Okay, let's see if we have some options maybe around that. Okay, I could still keep my messaging on AWS. I could move messaging to GCP. I could start using something like Nets, and Nets will enable me to do it. Nets is a managed service on CNF, so it's a CNCF solution that I can deploy my cluster, but complexity. So what I do, I'm gonna change queue service, but changing queue service, as we said, it's complex because I have to change the application code. And for all those of you who have been writing application code that relies on messaging tools, you know that is not as typically as isolated as it is managing storage. So you have logically application that really leaks with your messaging implementation there. What does the CNCF ecosystem has to offer? They offer Dapr. Dapr is a CNCF project that was open source in 2019 by Microsoft. Who here has used Dapr before or has used Dapr today? Nobody. Okay, interesting. So Dapr, how does it work? Very easy with our solution. Dapr is a way for us to say, okay, rather I can use the same idea of the container storage interface. I can deploy a sidecar container that stays next to my pod, and when the pod wants to make an external call to a third-party service, it's just going to call the sidecar container, and then the sidecar container calls a third party, which means that I can swap them behind the scenes. Today, Microservice 1 on AWS calls SNS that then reads the message from, gets a message in Microservice 2. What I can do, I can swap them. I can add Dapr on one side, Dapr on the other side. Microservice 1 talks to Dapr, that then talks to SNS, and then the other side happens. Which means that now swapping SNS for PubSub, it is transparent. That is Dapr role. Dapr is a middleware, is a layer between you and your cloud provider and your on-premises solution that really enable you to do what we wanted to do at the beginning. If you're looking at the left side of our slides here, we have now an easy solution where we say we're swapping environment variables on on one side for environment variables on the other side. I can now do what I wanted to do at the beginning. I can offload to the configuration and to a CNCF tool the concern of worrying about the cloud provider where I am. I can offload that to that, and I can then swap environment variables. Dapr is really effective at mediating access not only to publish and subscribe, to messaging, but to a subset of concerns, state management, actors, jobs, conversations, and secrets as well. So variety of concerns that Dapr has to worry about. Okay, but it's not perfect yet, Dapr. Why is it not perfect? Let's look at a specific example. So secrets is a concern that Dapr can worry about, right? Dapr can say, okay, I support a number of backend that you can use. You're an application, you used to go to HashiCorp Vault before, now you can go to Dapr, and I can swap Dapr's configuration behind the scenes between Secret Manager and HashiCorp Vault. This way, the application does not have to worry about anything. It's just transparent to it. But I transform my library change to pure configuration change. But there is a but. Okay, what is the but? The but is that if I do this, if I swap Dapr with HashiCorp with Secret Manager, well, what does the application do? What does Dapr do in this case? In this case, is a secret with 2 keys and 2 values. It's a multi-key value secret. It's a capability that exists only on HashiCorp Vault and does not exist on Secret Manager. So what can Dapr do in a case? If you're adding a middleware layer that supports a set of options, this middleware layer, the only thing it can do is to find the minimum common denominator. This is Dapr's limitation. In our example, we just made the cursor use of the flow, and we're like, thumbs up, no problem, Dapr is perfect. But if I'm making an advanced use, if I'm swapping topics live, if I'm using advanced capabilities of these backends, then Dapper may not be the right solution. But it's a very valid option. It's a CNCF project, and it's very advanced. Okay, let's get ready for our next question. This is a hard question, and who gets it right gets a t-shirt. So we change container registry, replace database engine, change a number of things. The application is up and running. All systems are up, our users are happy, developers can deploy, everything is fine. So why is the SRE team screaming at us? Why are they so upset with us? Any ideas? Grafana and Prometheus, not correct, not yet. Performance is not really a concern right now. Monitoring, hold that thought, we'll go to it in a second. Let me give you a hint. So the hint is we have GCP's console here, and we have Terraform on a trash can. So why do we have Terraform on a trash can? Perfect. Okay, you get a t-shirt. Okay, you get a t-shirt. Different providers. Okay, so we are an infra, we are a migration team. We don't know how to use Terraform or anything like this, and these are different providers. Even if I had all my tooling, all my S3 buckets and PubSub and everything on AWS, on Terraform, and I go to GCP, I have to rewrite everything, okay? That's the problem. Is there not a better solution? In 2 minutes, we can talk about Crossplane, which is a better solution. Anybody who's using Crossplane in their companies before? 2, 3, 4 people. Okay, perfect. So Crossplane, how does it work? I don't have to explain it too much. Is what I've been talked about today, a different, I think, session as well. It allows you to describe resources external to the cluster as YAML that then you can deploy and kubectl apply. It's a controller, you deploy on Kubernetes, you can have resources described as this YAML. This is a YAML for an S3 bucket. kubectl apply, this YAML, Crossplane sees it, says, okay, I'm gonna provision a bucket for you. You don't have to write it in Terraform. It's a replacement for infra code with Terraform. Okay, what I can do with Crossplane that is even more advanced, I can have composite resources, meaning rather than having a team saying, give me an S3 bucket, I can say, give me a bucket in general, give me a Postgres database in general, give me all of that. If I do it, then I can have this very nice layer where the developers say, give me a database, and the infra team configures Crossplane for which, if you're on GCP, you deploy Postgres with Cloud SQL. If you're on AWS, you deploy Postgres with RDS. So you can add this interface, this translation layer. So will it work? Yes, everything works. We're getting to the end of our session, so I'm going to go really quick right now on monitoring and point out only one obvious point. Cloud providers have hundreds of solutions for services. Monitoring solutions, there's many. AWS has CloudWatch, has Prometheus and Grafana as well. In this case, choosing a solution that is aligned to an open source standards allows us to be more portable than choosing one that is not. Moving your CloudWatch dashboards to GCP is much harder than moving your Grafana dashboards on GCP. Okay, we're at the end of our session. We have a few takeaways. So takeaway number one, the big problem is that Kubernetes as a platform is not feature complete. I cannot just rely on Kubernetes itself. I need to use cloud provider solutions or CNCF tooling that emulates all of this. Even today, in 2026, cloud portability remains hard work. But 5 things to keep in mind to show you how this thing can really be simplified. Number one, think about moving the portability concerns and external concerns from code into configuration. Using open source tooling like Dapper really enables you to simplify portability. Open source can help as well because choosing services, cloud provider services that are aligned to open source tools simplifies portability dramatically. Think about the fact that portability has a monetary cost. There is a cost attached to portability. So you can choose to pay this cost when you're designing your solution at the beginning and being really slow, or you can choose to pay this cost at the end of the solution when you're really doing the migration, but there's a cost attached to it. Folks, thanks a lot for coming for my session today.